or the angular momentum quantum number. It defines the shape and type of orbital occupied by the electron. It defines the shape and type of orbital occupied by an electron. So the angular momentum quantum number, it defines the shape and type of orbital occupied by an electron. Occupied by an electron. So the angular momentum quantum number, it talks about the shape and type of orbital in which the electrons occupy. Is that okay? So earlier on I said the electrons are not just located exactly on the shells, as we know from the modern structure of the atom, but the electrons are actually located in what we call orbitals. These orbitals are regions of empty spaces within the energy levels where we locate the electrons. Is that okay? So we can call it a subshell. So if this is a main shell, there is a certain subshell somewhere which is occupying the electron, and we call it orbital. And orbitals, we can understand orbitals once we move to the next quantum number, that is the azimuthal or the angular momentum quantum number. And I said it defines the shape and type of orbitals occupied by an electron. Now, let's break it down. So let's dive deep into the angular momentum quantum number. So the angular momentum quantum number can have values from 0. So the angular momentum or the azimuthal, that's the L, it can have values from 0, it can be 1, it can be 2, it can be 3, it can be 4. Is that okay? But anytime we are talking about the azimuthal or the angular momentum quantum number, its values has interpretation. Each value has a meaning. If we see 0 for the angular momentum, it has a meaning. If you see 1, it has a meaning. If you see 2, it has a meaning. If you see 3, there is a meaning, and also if you see 4, there is a meaning. The 0 here represents a certain orbital. It is known as the s orbital. So the 0 here is known as the s orbital, or it indicates an orbital called the s orbital. The 1 here represents an orbital called the p orbital. The 2 represents an orbital called the d orbital. The 3 represents the f orbital, and then the 4 represents the g orbital. Is that okay? So anytime you have an angular momentum value of 0, it simply means you're talking about an orbital that is known as the s orbital. If we have 1, you're talking about an orbital, and that orbital is the p orbital. If you're talking about 2, it is a d orbital. If it is 3, it is an f orbital. If it is 4, it is a g orbital. Is that okay? What are these orbitals? Orbitals are regions of empty spaces within the energy level where there is a high probability of locating an electron. And these are the type of orbitals that we have. So the angular momentum defines the shape and type of these orbitals. It defines the shape and the types of the orbitals we have in each energy level. So we have the s orbital, we have the p orbital, we have the d orbital, we have the f orbital, and we have the g orbital. Is that okay? Now, since we're talking about the shape, we are going to consider the shape of the s and then the p orbital. The s orbital is spherical. The s orbital is spherical. So this is the s orbital. The p orbital looks like a dumbbell in shape. The p orbital looks like a dumbbell in shape. It looks like this. This is the shape of the p orbital. So these are the p orbitals. So the s orbital is spherical, the p orbital is dumbbell in shape. So this is the p orbital. And then this is the s orbital. For the remaining orbitals, they are complex in shape. They are complex in shape. Is that okay? So in our lesson, we'll be looking at the s orbital, its shape is spherical, and then these are the shapes of the p orbital. It can exist in this three form we will explain in our next quantum number. Is that okay? Alright, in addition to this, another thing we need to know about these orbitals is the number of electrons that can be located in each orbital. Is that okay? So the s orbital accommodates a maximum number of 2 electrons. It accommodates a maximum number of 2 electrons. That is the s orbital. Is that okay? It accommodates a maximum number of 2 electrons. In the p orbital, the maximum we can allocate over there is 6 electrons. The d orbital, the maximum electron that can be located in a d orbital is 10 electrons. For the f orbital, the maximum is 14 electrons. And then for the g, we have 18 electrons. Is that okay? So we can locate a maximum number of 2 electrons in the s orbital, a maximum number of 6 in the p orbital, 10 in the d orbital, 14 in the f orbital, and then 18 in the g orbital. Now let's look at a simple explanation of the principal quantum number and then the azimuthal quantum number. We said that the principal quantum number defines the main energy level of the orbitals in which electrons occupy. And in addition to that, we said the azimuthal or the angular momentum quantum number defines the shape and type of orbital an electron is occupying. And I said the azimuthal can have values from 0, 1, 2, 3, 4 in that order. Each value or each number represents an orbital. If it is 0, it represents an s orbital. If it is 1, it represents a p orbital. If it is 2, it represents a d orbital. If it is 3, an f orbital. And if it is 4, a g orbital. Is that okay? Don't forget, I said an orbital is a region of empty space where we locate an electron. Each orbital has its maximum number of electrons that can be located there. The s orbital can accommodate 2 electrons. The p accommodates 6 electrons. The d accommodates 10. The f is 14. And the g accommodates 18 electrons. Is that okay? Now let's take a simple structure of the atom. Let's take a simple structure of the atom. So I have my neutrons and protons making up the nucleus. Is that okay? And then I have the shells. Alright, so with the 2 quantum numbers so far, we are saying that the principal quantum number has a donation n, and it talks about the shells or the energy level. So I said in a simple form, it represents the shells. So I said n can have integer values from 1. So the first one, or the first shell indicates n is equal to 1. The second shell indicates n is equal to 2. The third is n is equal to 3 in that order. Is that okay? Now, the azimuthal quantum number also gives an idea about the orbitals that is present in each of these shells or energy level. Is that okay? So it simply means that with the help of these energy levels, we can also identify the type of orbitals present in each energy level. How do we know the type of orbitals present in each energy level? We use a value range, and this range is the value range, and then this range is from 0 to n minus 1. From 0 to n minus 1. So this range is going to give us an idea about the type of orbitals present in each energy level. It is going to give us an idea about the type of orbitals present in each energy level. We already know that we have the s orbital, it accommodates 2 electrons. We have the p orbital, it accommodates 6. We have the d, which accommodates 10. The f accommodates 14. How do we know the type of orbitals present in each energy level?